Good day, viewers. You are welcome and happy to see you here again. Today we have these interesting equations, which is e to the power x equals x to the power of 2. I want to find the value of x that satisfy these equations. Remember that e here is known as Euler, that is the exponent. And to solve this, the first step we take is we try to introduce ln to both sides, which is the natural logarithm as ln e to the power x equals ln x to the power of 2. So after considering this, we know that ln and e both are inverse to each other. So they cancelled, as we have this as x equals ln x to the power of 2. But according to the rule of logarithm, anytime we have a power of this on this number, we take it back. Therefore, we have x equals 2 ln x. So then let's try to divide both sides by x. So by dividing both sides by x, we have this cancelled. It remains 1 here. So if 1 equals 2 ln x divided by x. So by dividing both sides by 2 again, we have this cancelled. Then we can write this as ln x divided by x equals 1 divided by 2. So this is the same thing as when we have 1 over 2 here and ln x divided by x. But let's try to look at this. At this numerator we have ln x and here is 1. Here is x and here is 2. So nothing is equal. We cannot compare and we cannot conclude the answer at this stage. So here is where we come. Suppose we have this as 1 divided by x. So we can write this thing as ln x multiplied by x raised to the power of minus 1. Because 1 over x is the same thing as x to the power of minus 1. And everything equals 1 divided by 2. So let's try to borrow the knowledge of this. Suppose we have something like omega of a exponential of a. So we consider this as a. Here is the principle of Lambert omega function. That is, this coefficient and the power of this exponent must be the same before we can choose the answer to be the power or the coefficient, which is a. I want to make sure that this left hand side looks similar to what we have here before we can conclude. So the next thing we are going to do here is, let's try to introduce e and ln to this x to the power of minus 1. As we can write this thing as ln x multiplied by e to the power of ln x raised to the power minus 1. So this is the same thing as x to the power minus 1 because e and ln, they are inverse to each other, they cancelled. So I just introduce it to get the result of this. Everything equals 1 divided by 2. So then let's take this negative here. We have ln x multiplied by e to the power of negative ln x equals 1 divided by 2. So but because we have something like this, so we have e to the power of minus ln x and we still have ln x here, but what this is missing is negative. That is, we introduce negative to both sides. So by doing that, we have minus ln x multiplied by e to the power of minus ln x equals minus 1 divided by 2. So we can now introduce the function, which is Lambert W functions, to both sides. So here becomes omega of minus ln x multiplied by e to the power of minus ln x. Everything equals omega of minus 1 divided by 2. So then we take only minus ln x according to the rule. Everything equals omega of minus 1 divided by 2. So then we need x, and what to do here is, suppose we take this one back. If this is just like 1, when we take it to the power of this x, we have ln x raised to the power minus 1 equals omega of minus 1 divided by 2. So let's try to introduce exponents to both sides. So by doing that, we have e to the power of ln x raised to the power minus 1 equals e to the power of this. So with this cancelled, we have x to the power of minus 1 equals e to the power of omega of minus 1 divided by 2. And to get x here, suppose we raised both sides of this equation by minus 1, or if we can't do that, we can just say x to the power of minus 1 is the same thing as 1 divided by x. Everything equals e to the power of omega of minus 1 divided by 2. So when we cross multiply and we divide, so we can just conclude that the value of x here is the same thing as 1 divided by e to the power of omega of minus 1 divided by 2. And here is the result to this problem. Remember that this comes with real and complex, or any of the two. So we can drop the answers, our few on these final answers. If it is the final answer, or we still have another answers, that is if it is 2 or 1, because according to the equations we have quadratic here and here is exponent, that is the answer is probably 2 or 3. So here is how to solve this. Thanks for watching, and if you are new here to this channel and you find this video interesting, please do well to like, share and subscribe, and turn on the notification bell for more videos. See you in the next class. Never stop learning. Bye bye.